All right, so here we are with the 7-1 assignment from PreCalc. So here are the problems that we're going to go through. And of course, you can go ahead and fast forward to any of these problems that you would like to check out. And of course, this sheet, once I'm done with it, will be scanned onto Headrest. So you can kind of skip around on that as well. So we're going to just work through them in order. So first one is number 1. In number 1 here in the book, they're saying that you need to determine whether the ordered pair is a solution. So really, all we need to do is plug in the x value to the x and the y value to the y for both of these equations and see if it works. So in number 1, the first equation that we have is 5x minus 2y equals 8. They want you to check out if the coordinate 0, 4 works. And we do not necessarily need to plug it into the second equation unless it works in the first equation. So if this is our x and this is our y, we're going to take 5 times 0, subtract 2 times 4, and maybe that equals 8. So 5 times 0 is 0, and then we're going to subtract 8, and 8, does not equal 8. So that means that A is not a solution. All right, so then we'll try the next one. So we want 5x minus 2y again and see if it equals 8. But now in part B, they want you to plug in 2 and 1. So we're going to plug in a 2 for the x, a 1 for the y, and get 5 times 2 minus 2 times 1. So we're going to be doing a lot of very basic algebra here. And 10 minus 2 is 8, and 8 equals 8. So it is the solution to this equation, but that means that we then need to try it in the next equation. So the next equation that was in the system is 2x minus 3y equals 1. And so our x value, again, is 2. Plug in a 2, and then subtract 3 times 1. 2 times 2 is 4, minus 3, and 4 minus 3 is 1. So that means this is a solution to part B here. Then in part C, they want you to try a different equation into the 5x minus 2y equals 8. And now they want you to try the coordinate negative 2, negative 9. And so we'll plug in a negative 2 and a negative 9. So 5 times negative 2 minus 2 times negative 9 equals 8. Maybe. So negative 10 plus 18. And it turns out that that is 8. So that works in that one, which means we're going to have to check the second equation. So 2x minus 3y makes 2 times negative 2 for our x, minus 3 times negative 9, and hopefully that equals 1. Otherwise, it's not a solution. So negative 4 plus 27 is certainly not 1. It's 23. And so in that case, this is not a solution. All right, so that was part A, B, and C for number 1. Number 2 has the same idea, only now we have a quadratic equation. So we're going to take the first equation, which is y equals x squared minus 6x plus 5. And in part A, they want you to check if 2, negative 3 works. All right, and so 2 is our x and y is negative 3. And so we're going to plug in a negative 3 for the y and see if that equals 2 squared minus 6 times 2 plus 5. So we're going to see if 4 minus 12 plus 5 is negative 3. Negative 8 plus 5, woohoo, it works. So then we move on to the next equation, which is in the system, and it says it's y equals 2x minus 7. So we're plugging in a negative 3 for the y, and then a 2 for the x. And double checking if 4 minus 7 does equal negative 3, and it does. So this is a solution in part A. All right, then we move on to part B, where they want you to try 1, negative 5. So same equation set. But now they are giving you 1, negative 5. And so your y value is negative 5. X value is 1. And we're going to double check if this works. So 1 minus 6 plus 5. 1 minus 6 is negative 5. Oh, negative 5 is certainly not 0. So in this case, this is not a solution. All right. Moving on to the next problem. We're trying the equation again. So this is number 2 continued. We have y equals x squared minus 6x plus 5. And in part C, they want you to check 6, 5. So we're going to double check if our y of 5 is going to equal 6 squared minus 6 times 6 plus 5. And so we're wondering if 36 minus 36 plus 5 is 5, and it turns out it is because it's going to be 0 plus 5. So now we just need to check our next equation, which was 2x minus 7. So the x is 6 and the y is 5. So we're going to see if 2 times 6 minus 7 equals 5, meaning 14 minus 7. And sadly, 5 is not equal to 7. So this is not a solution. All right. So that was number 1 and 2. Then, according to our assignment list, we're moving on to 7. So in 7 through 10, the directions are to solve the system by substitution. So remember, that means you solve one equation for one variable and then plug it into the next one. So we're going to write out the work for number 7 here. So number 7 gives you the system of 2x minus 3y equals negative 7, and then 4x plus 5y equals 8. So lots of heavy algebra here. So if we go ahead and solve this one that's on the bottom for a variable and plug it in, this will help us. So I'm going to move this 4x over and get 5y equal to negative 4x plus 8. Divide by 5. And we get a y of negative 4/5 x plus 8/5. That's gross. But we're going to plug it into this original equation up here. So we're going to get 2x minus 3 and then this new y equation. And hopefully that will work out to equal negative 7. We're going to plug in negative 4/5 x plus 8/5. And so to solve, we're going to distribute this 3. So we have 2x minus, actually we'll have plus 12/5 x. And then minus 24/5 equals negative 7. But we have 2 x's and 12/5 x's. And 12/5 is actually 2.4. So in that case, we will have 4.4 x's from these two together, minus 24/5, which is 4.8. And so we'll add 4.8. And get 4.4 x's equals negative 2.2. Divide that all by 4.4. And we finally get our x of negative a half. All right, so if our x is negative a half, that means that we plug that back into one of the original equations. So we take 2, and instead of an x, we'll put in negative 0.5 minus 3y equals negative 7 in order to solve for our y value. So negative 0.5 makes this negative 1. Add a 1. Divide by negative 3. And we get a 2. So finally, the coordinate of where they meet is going to be negative 0.5, 2. In number 7. Okay, then we move on to number 8 because we're doing 7 through 10. So 8 is going to be solved the same way. This is because it says substitution. So 3x plus 2y equals negative 5. 2x minus 5y equals negative 16. And so we'll do as we did before, which is rewrite the bottom one as y equals. And so now we have negative 5y equals negative 2x minus 16. Divide everything by negative 5, and we get a y of 2/5 x plus 16/5. Or because we converted it into fractions, decimals last time, we'll just do that again. And plus 3.2. Okay. So now we're going to use that equation to plug it in because, again, we're substituting in. So we're going to substitute this y in for this y. Please don't substitute it into this second equation because that's the one we used to rewrite. So you'll actually get 0 equals 0 and wonder what happened. So we're going to plug in our y equation that we got here in order to solve for the x. So this is 0.4 x's plus 3.2. And then we're going to solve for x. So we'll distribute the 2 and get 3x plus 0.8 x. And don't know why I did that, but 6.4 equals negative 5. Combining our x's together makes 3.8 x's plus 6.4. Subtract a 6.4. And we get 3.8 x's equals negative 11.4. When we divide by 3.8, I assume that's going to get a nice number, but we'll check. Negative 3. So now that we have negative 3, we plug a negative 3 back into the original equation, one of them up here. So we're going to have 3 times negative 3 plus 2 times y equals negative 5 in order to find out what our y value is. So plugging in a negative 3 instead of the x leaves you with negative 9. And we'll move the 9 over. To get 4. Divide by 2, and we get a y of 2, which means that our coordinate answer is negative 3, 2. Of course, you can double check if that works without looking at the answer key by plugging them both in here and seeing if they work, like you did in number 1 and 2. All right, then moving on to the same process for number 9. Number 9 gives you x minus 3y equals 6, and negative 2x plus 6y equals 4. So we will rewrite this bottom equation and get 6y equals 2x plus 4. Divide everything by 6 and get a y of 1/3 x plus 2/3. All right, then we're going to rewrite and insert that y value in for this equation. So we'll have it here. We have 1/3 x plus 2/3. And now we're going to distribute the 3. So we'll have x minus 1x plus, oh, that's a negative 3, so minus 2. Combine our two x's together and we get 1x minus 1x, and so there are no x's. And so we end up canceling our x's and being left with negative 2 equals 6. And so remember that when this happens, this is a false statement. And from our notes, if there was a false statement, let's grab them. A false statement said that there was no solution because these were parallel lines. So our answer is no solution, because they must have the same slope. Now, the way that they hide that is because they write this in standard notation, and so you don't necessarily automatically see that if you divided everything by negative 2, you'd get the equation with the same slopes. So anyway, no solution for number 9. Darn it. All right. Then the last one in this section is number 10. So in number 10, we have 3x minus y equals negative 2, and negative 9x plus 3y equals 6. So we will solve this bottom equation for y. Divide by 3 and get a y of 3x plus 2. That's nice. Then we plug in this new y in for this top equation for y. So 3x minus this new equation should equal negative 2. And so we get 3x plus 2. And then we will distribute the negative 1 into both of these. So we have 3x minus 3x minus 2 equals negative 2. And so 3x minus 3x makes 0 x's. And so that cancels to leave us with a true statement. And remember back in our notes that if we have a true statement, we actually have infinite solutions for true statements because it's actually the same line. So in that case, there are infinite solutions because the lines are exactly the same equation. However, again, you can't see that necessarily by just looking at it, but if you divide each of these coefficients by 3, negative 3, you will get this top equation. So, all right, so that's number 10. Now the homework says that you're going to go to number 13 and 14. So in 13 and 14, you need to solve algebraically and support your answer graphically. So when they say graphically, they do just mean graph it on the graphing calculator and check to see that they meet where you said it would meet. So you don't have to necessarily graph it by hand, as much as I'm sure you would love to do that. So we're actually doing number 13 and not 11. Okay. Yep. 13. Okay. So in number 13, we have y equals 6x squared and 7 plus y, 7x plus y equals 3. So I'm going to be fancy here, and this is probably the reason that they actually wrote it like this, because in the book, you'll notice that they wrote 7x plus y, and then they wrote this other one as y equals 6x squared. So notice that they actually already set it up to be distributed, this numerator, by a -1 to eliminate, because if I make this a -1 and this a -6, I can add them and end up getting rid of my y's. So the new equations that I have are -y equals -6x squared. So you have to distribute the negative to both of them. And then the bottom equation already has the opposite, so it already has a plus y, so we don't need to multiply by anything. In which case, we are going to add them, and now we'll have 7 x's, no y's, and that's going to equal -6x squared plus 3. Remember, if there's ever a squared, that means that you're going to try to rewrite it so that everything is on one side so that you can use the quadratic equation or factoring. So 0 is going to equal -6x squared minus 7x plus 3. And again, that one is trickier to factor, so instead we're just going to use the quadratic equation with an a of -6, a b of -7, and a c of 3. So the quadratic equation says that x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Here I am at my house singing to myself. Okay, so -7 is going to be just a +7, which we will add and subtract a b squared. And so that means that I'm going to take -7, the quantity, and square it, which will make it positive. And then our a value is -6, and our c value is 3. And all of that is going to be divided by 2 times -6, which is our a value. All right, remember that this is all to get our x coordinates of where these two will meet. So we're going to take 7 and add and subtract the square root of 49 plus, this -7, the quantity squared is 49. Oops, -4 times 3. And then this is going to result in a +72. All of that over -12. And so that means that we're actually going to get the square root of 49 plus 72. Ooh, how nice is that? It's a 121, which is 11. So we'll actually get real numbers here. All right, so 7 plus or minus 11 over -12 means that one of our x values is 18 divided by -12, which is -1.5, or 7 minus 11, which is -4, divided by -12, and so 1/3. So those are our two x values, and so in order to get our y values, we plug them back up into one of the equations, doesn't matter which one, and get our y value. So our y value, if we plug in a -1.5 here, so -1.5 squared times 6 makes 13.5. And then plugging in a third up here, 1/3 squared times 6 is 2/3. So our ending results are -1.5, 13.5, and 1/3, 2/3, for where those two meet. So it does say that you want to support your answer graphically, which means that if you grab the graphing calculator, as long as you are in function mode, now that we are not doing polar equations, you could graph 6x squared. Whoops, I just deleted it. And 7x, oh, that one needs to be rewritten so that I can graph it as y equals negative 7x plus 3. Okay. So negative 7x plus 3. Then to get an automatic standard window, you can go to Zoom and then down to number 6 where it says standard. So you can see our quadratic equation of 6x squared and then our linear line. And we needed to double check that it intersects at negative 1.5. So on your trace, you can just type in negative 1.5. It comes up down here, press enter, and 13.5 is the answer. And then over here, you can also press 1/3, right? And it tells you that 0.6 repeating is your answer. So I guess I'm just going to write check because we checked it with the calculator. Okay. So then the next problem is number 14. So in number 14, same directions as number 13, and in fact going to be the same operation. Okay, so they try to be a little bit tricky here and get you to see that this x is over here. And so if we rewrite this top equation, we can move this x over to this side and have negative x with a 2x, a positive y and a positive y. And this top one is going to equal 2x squared, but the bottom one equals 20. But we can do the same process as we did before and multiply that top row so that we can get a negative sign in front of the y. And so we will be left with positive x minus y equals negative 2x squared, flipping all those signs. And to that, we're going to add 2x plus y equals 20. So a little bit of elimination. So that means that 1 and 2 will make 3 x's. The y's will cancel, and that will equal negative 2x squared plus 20. Again, there's an x squared, and so now we need to rewrite this so that we have all of the variables on one side in order to be able to factor or use the quadratic equation. This unit is going to be pretty algebra heavy, so we're going to get used to kind of doing all our steps here. Of course, since I am the teacher, I am taking the time to write each step, but if you can skip a few of these, that is perfectly acceptable. But I doubt without writing a few of these steps, you'll actually get to these appropriate symbols and signs. So we're going to use our quadratic equation, which says that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now we're going to plug in each of these values in order to get our x's. And so we need a negative b, but b is already negative, so positive. And then we'll add b squared, which is negative 3 again. And 4 times a, which is negative 2, and c, which is 20. And that's all going to be divided by 2 times a, which is negative 2. All right, so working in our discriminant first, the stuff that's under the parenthesis, under the square root, gives us 9, and then 8 times 20. So 160. And that's going to be divided by negative 4. And so we'll get plus or minus the square root of 169. And so that actually means we're going to get, we're going to get 3 plus or minus 13 over negative 4. So Our values are going to be 3 plus 13, which is 16 over negative 4, which makes negative 4. Or we're going to get 3 minus 13, which is going to leave us with negative 10. And negative 10 divided by negative 4. So 2.5. So we're going to take these numbers, plug them back into one of these equations for our x in order to get our y. So the y value, when you plug in a negative 4, is actually a little bit less than helpful to just say. So we're going to get negative 8 plus y equals 20, or the fact that y is 28. And then when you plug in a 2.5, it's 2 times 2.5 plus y equals 20. So 5 plus y equals 20. So y is 15. All right, so our two solutions are going to be negative 428 and 2.515. All right, so that was number 14. Moving on to the next section, wants you to work 21 through 24. So 21 through 24 have the directions solve the system by elimination, which is what we had been using up here in number 14 and 13. So we should be well on our way to doing that. So number 21 has two linear equations, so it'll be a little less time consuming than this quadratic stuff. So 3x minus 2y equals 8. And then we also have 5x plus 4y equals 28. So I'm looking at both of these and thinking which coefficient is easiest to make opposite. And so since we already technically have an opposite value here of negative and positive, I'm just going to make the numerator, or the top equation, a negative 4. So how do I make a negative 2 into a negative 4? I'm going to multiply everything by 2. So now my equation is going to be 6x when multiplying by 2 minus 4y equals 8. Oops, sorry, 16. Most people forget to multiply that last one by 2. And then the other equation, which we do nothing to because it already has the opposite coefficient. And then we add them. So now we're going to have 11 x's, no y's, and 44, which is very nicely divided. And so we get an x of 4. Now all I need to do is plug that x of 4 back into one of the equations. So I'm going to plug it back into this second one. And solve. So we're going to get 20 plus 4y equals 28. Subtract out a 20. And get 4y equals 8. Or a y of 2. So that means our answer is going to be 4, 2 for where those two lines meet. All right. Then we move on to 22, which is also a set of two linear equations that we're going to solve by elimination. Of course, you can multiply by whatever value you would like to get a different leading coefficient to be opposite. So again, I just look for ones that are already the same number or already positive and negative, so I don't have to deal with too many negatives and positives. Let's see, double check that that's the right equations, because I write things wrong a lot. Okay. So it turns out that, let's see, these ones are opposite numbers when they're symbols, and these ones are not. So I'm going to multiply this top row by 4 and this bottom row by 5. So basically the opposite coefficient. But of course, I'm not going to do anything to a negative because one's already negative and one's already positive. So our new equations are going to be 16x from 4 times 4 minus 20y equals 92. Oh, negative 92. And then over here we'll get 15x plus 20y, again because you wanted opposites, equal to 30. And then we'll add them together. So we're going to get 31 x's, no y's, and that's going to equal negative 62, which is easily divisible by 31, and so x is negative 2. And now we need to plug the negative 2 back into one of the original equations. So plug it back into the second one because it's got less high numbers. Gives us negative 6 plus 4y, or adding a 6 to get 12, or dividing by 4 to get a 3. So that means our coordinate is negative 2, 3, for where those two lines meet. Okay, next problem is the same type of problem. So now we're going to try to solve by elimination. And in number 23, again, two linear equations. We have 2x minus 4y equals negative 10, and negative 3x plus 6y equals negative 21. Just checking that I wrote it right. Okay. So just like the previous one, there aren't necessarily any immediate opposites, and so these are the smaller numbers that I'll try to make opposite. So I'm going to multiply this numerator, or the top equation, by 3, and then this bottom equation by 2. Again, that's because the numerator, or the top equation, is now going to have 6x, and the bottom equation will have negative 6x, and so those will end up eliminating in our elimination step. Then 3 times 4 makes negative 12y, and that equals negative 30. And then 2 times 6 makes positive 12y. Whoops, that's 1. And that's going to equal negative 42. All right. And so if we add the top and the bottom row, we're going to realize that something slightly awkward happens. And oh my gosh, we add them and get 0 x's and 0 y's equal to negative 72. So 0 somehow equals negative 72. And so remember that sometimes false statements will occur, and when false statements occur, that means that you have no solution because they are parallel lines. So this one has no solution. Okay, then in number 24, I'm just going to take a guess that it's probably going to have a true statement and therefore have infinite solutions, but here we go. So in number 24, we have 2x minus 4y equals 8, and negative x plus 2y equals negative 4. All right, I'm going to multiply the bottom row by 2 to get an opposite out front here, which means that we will be left with the same top equation of 2x minus 4y equals 8. But then the bottom equation has become negative 2x minus 4y minus 8. And so hopefully you can see that those are all in fact opposites, which means if we add the top and bottom equation, we're going to get 0 x's, 0 y's, and 0, which means 0 equals 0, or a true statement, which means there are infinite solutions. That's an infinity symbol. All right. Okay, So then we move on to 27 through 30. So on the next page. 27 through 30, we're going to use the graph to estimate any solutions of the system. So we're just going to take a gander at the graph and estimate what a solution might be. For instance, in number 27, you can clearly see it's at 0. And then based on this scale down here, they say that this goes to -3, and this goes to 5. And then this goes up by 1s because it's going up to 3 and down to 3. So we know that this point is going to be 0, 1. So we will write down number 27. So in number 27, again, we're just looking at the graph. And of course, we can verify with these equations, but it just says estimate. So in that case, I am estimating that this coordinate point, which is at 0, 1, is one of the solutions because that's where they meet. And then over here at 1, 2, 3, down 2. All right, then in number 28, we're going to estimate again. Now we have 2 lines that meet, and so you see here that we are going by 1, so each of these tick marks is worth 1. And so if we're going to meet over here, that's at 1.5 and 1. And of course, we could plug in a 1.5, for instance, into this equation, which would make 3 plus 1, and that's 4. So it does actually work out if you check it. All right, then number 29. We've got 2 lines that are parallel, and it says that we need to estimate the solutions, and so there are no solutions to parallel lines. So no. And then number 30 has a circle with a quadratic, which is very exciting because notice that there are 3 solutions, so that's a whopper. All right. So the easiest one is to go down here at the y-axis. So at -1, 2, 3, 4, so 0, -4 is one of the intercepts. We also have going over here -2, no, -2.5 probably, and then up at 1, 2, 3. So -2.5 and 3. And then because it's a quadratic, the next coordinate is probably going to be +2.5. Oh, that is not a 3. And so again, just verifying, it doesn't really look like it's at 3. So yeah, 2.5-ish. Let's see, 3. We could, of course, plug in a 3 for this y, for instance, and solve to get our x, which is going to be a square root of 7, which is probably 2 point something. Yeah, so it turns out that via algebra, you're actually going to get -2.6458 for both of these, well, plus or minus, or the square root of 7. And that's just through algebra. But of course, if you had 2 point something, you're okay there. All right. Then the next problems are 35 through 38. So 35 through 38 are down here, and they say that you need to solve the system graphically and support your answer numerically, which just means plug them in to see if it actually worked. So we're going to get out our grapher, if you will, and in number 35, we are given the equations, the natural log of x and 1 equals 2x plus y, which is mean because it is not written as y equals, and if we're using a grapher, that means that we're going to have to solve this. So We'll subtract a 2x over to this side and end with an equation of y equals negative 2x plus 1. So we're going to graph this equation and this equation and try to find where they meet. So in your calculator, we are going to graph the first equation, which is natural log of x, and then the second equation, which is negative 2x plus 1. All right. And so it turns out that you could potentially see where they meet. Sort of. Of course, this window is much too big for this, so you can change your window. It looked like it was kind of around before 3, so I'm going to do 3. I'm going to actually just do 0. X's, yep. And then the Y's, I'm going to do maximum negative 3. All right, so let's see where that was. Okay, and so taking a look at that, it turns out that we can't necessarily give an exact answer of that until we calculate. So I did second calc, the intersection. So if we go through and press number 5, it's going to ask for your first curve, which notice it's on this natural log. And then the second curve, because notice in your y equals, you could have had like 10 graphs. So they just want to make sure that they know which one you're talking about. So first curve, second curve, and then they want you to guess, because again, like we've seen, there could be 3 intersections. So you need to move your cursor so that it's around where you want your coordinate to be. So that means that our answer of our intersection is 0.6874 comma negative 0.3748. All right. And then, of course, we could show that numerically by plugging in this number for the x, and hopefully we would get this for the y, and then this number for this x and y, and hopefully we would get 1, which it does look kind of like it doubles. So that's what they're asking for there. Then moving on all the way through 38. So number 36 gives you y equals 3 cosine of x, which is going to repeat a bunch, and then 1 equals 2x minus y, which again we're going to have to solve. So if you add a y over to this side and subtract a 1 over to that side, you're going to be left with y equals 2x minus 1. So we will graph both of those equations and find where they meet. So 3 cosine x, and you are going to want to be in radian mode because of that. The fact that you are using standard equation here, you're not using, they won't meet if you use degrees, because degrees are going to be between 0 and 360, and this one is not going to reach that high. So again, radian mode, and then y equals 2x minus 1. All right. So we also have a weird window, so you can go to zoom and then standard, and you'll get your 3 cosine because it's stretched up 3, and then apparently the 1 intersection value. So again, you could try to zoom in and see where that is, or you can just go to second calc and go down to intersect and basically just press enter 3 times, and then they will tell you that the intersection is going to be at 1.1342366. Don't know why I wrote all of them. And then 1.2685. All right, and again, to check algebraically, you can plug in this for your x value and see if you get a y. And just for fun, I'm going to drop my calculator and then do that. All right, so cosine of 1.1342366 And then that times 3 is hopefully 1.2685, which it is. All right, so anyway, just checking. All right, then we have number 37. And in number 37, you have x cubed minus 4. And then 4 equals x minus 2y, because you couldn't just give it to you in standard form, or graphing format. So I'm going to subtract a 4 over and get 0. Oh, so that's minus. And then add a 2y. Decided to go about this in a very awkward way. And then divide by 2. So our equation is y equals a half x minus 2. So we're going to graph that equation and that equation. Right, so the first equation is x cubed minus 4x, and then the next equation is a half x minus 2. So depending on how you went about graphing this, you might want to put x cubed in parentheses. You might have 0.5, but either way, we're going to graph on our standard window and see the cubic there, and then see the linear equation, hitting it 3 times. So we're going to second trace or calc those 3 intersection points. And so this is where it is actually going to be helpful to realize that you're on the first curve, which is the cubic, you're on the second curve, which is the linear, and you want the intersection that is there. And so one of the intersection points is going to be negative 2.3160, and then negative 3.1580. Then we get to do second calc again. Do not just trace, because you are not going to get anywhere near what the answer actually is. Second curve, and then again, we want this point versus that point, so you want to make your cursor as close to that intersection as possible, which gives you 0.4671 and negative 1.7665. And then the last point, again, calculating the intersection, first curve, second curve, but then going on that place to this intersection point. You have 1.8489 and negative 1.0756. Those are all the 3 coordinates of where this trinomial hits. This cubic hits that linear. All right, well, that was exciting. And then the last one is number 38. And so in number 38, you are given a quadratic equation and a linear equation. So the quadratic equation is x squared minus 3x minus 5. And the linear equation is 1 minus 2x minus y. 1 equals 2x minus y. And so if we add a y over to the other side and subtract a 1 over to the other side, we're going to be left with y equals 2x minus 1. So we're going to graph those 2 equations. And so you'll clear out your y equals, type x squared minus 3x minus 5, and then the next one, 2x minus 1. Lots of movement. There you go. When you graph it, you get your quadratic and then your linear going through it. That one's a little up there. And so we're going to calculate that again, second trace, go down to intersect, and it's asking the first curve, the second curve, and we want this point. So we'll press enter for that. And it does a little thinking and then tells you that your intersection point is negative 0.7016 and negative 2.4031. The other one, again, second trace, going down to intersect, we're going to press enter twice because it already hops from one curve to the next. But then we're going to scroll up here and press enter, and that gets us our next coordinate of 5.7016 and 10.4031. All right. So again, if they give you things on the answer key for the book that has square roots and stuff, it's because they did it algebraically to get the exact values, but clearly we used it graphically with our graphing calculator. So hopefully that helped you through the 7-1 assignment, and that is the first one for Chapter 7.